Welcome back to Solidity Fridays. I'm here with the wonderful Rory and William Schwab, and today we're doing Gearbox. This is going to be one of our more going in blind episodes, I believe. I don't think Will nor I even know really what Gearbox does. I know it has something to do with leverage, but other than that, I'm pretty clueless. And just at the quick glance at the repo, we're also going to have to feel our way in the dark there. So, William, what's up, man?
Yeah,
What are you thinking of
it's
Gearbox?
good. I'm thinking. I hope my audio works. Actually, like you said, you can see from the level. I remember seeing because Ivan from Lobsters is I think involved. I'm not exactly even sure how. Um, so I looked at the app. Leverage, of course, is I think kind of what every investor says is the best way to absolutely destroy whatever kind of principle you have. I believe that set up a kind of a safer form of leverage also, which I think is supposed to be one of the big pulls here. But yeah, I'm really excited to dive. There's a lot of kind of to control the space. Very excited about Gearbox. So I think that's one of the things that makes it really, really a great choice.
So yeah, well, you were cutting out a little bit there, but what did come through was very excited about Gearbox in the space, and I agree. That's what I'm seeing on Twitter as well. Like everyone's pretty hyped.
Yeah.
Cool. So,
should we start with a little bit of a description about what leverage is?
Yeah,
I think it might be the right place to start.
Yeah, I can give it a shot. So, leverage, I think, basically means debt, and it's in the sort of special case where you're using debt to kind of amplify or magnify some sort of financial position you're taking. So one thing that's pretty common in crypto is trading. You would trade with options, which kind of have a built-in leverage, or just straight up borrow money as debt and then use that money to trade. That's kind of pretty direct, explicit leverage. And the effect is that it allows you to trade with some small amount of money that you've put up as you've put that at risk, and then borrow more money on top of that. So then when the prices go up or when you're winning on your position, your profits are magnified based on that leverage ratio. So say it's 10-1, like here on Gearbox, it says 10x leverage. An example might be that you put up $1,000 and then you borrow $10,000, or rather, I think $9,000. So you get sort of a 10x position of that 1,000. And you invest that in, say, Sushi Swap or the Sushi token, and the Sushi token goes up 50%, then what you should see is that your position goes up 10 times 50%, which I think should be around 500%. So that would be, what is that? That was like a
winning. That's winning.
Yeah, that's definitely winning. So 100% is it's winning. But then the sort of downside, you can't just have that sort of power without some sort of magnified risk or downside as well.
With great power comes great liquidation.
Exactly. So on the downside, you have the same effect where if you put up your $1,000 and they add in, you borrow $9,000 on top of that, then your losses on the downside when the position goes down are magnified in the same way. So if your position was to drop 5% and it's times 10, then that would be a 50% drop in the position. So you'd be at a 50% loss. And then obviously that can only go so far. When you hit 10% drop in the underlying token, 10 times 10% is 100%. So at that point, you should be liquidated. because your position should be 100% down. You've lost everything. And so what happens then, there'll be some sort of mechanism on these exchanges or these leverage protocols to basically take the $1,000 that you put up in the beginning and then sell it off, liquidating it, and then closing out the position. So you lose everything in that case. So that is sort of the magnified risk that goes with the magnified reward.
Awesome. Just, I mean, obviously we're not giving any financial advice here. A number of the kind of traders who are more well-known on Twitter recommend staying away from leverage. We'll see also if Gearbox has some kind of protection in place to try and like stopgap or like, you know, prevent people from getting absolutely wrecked, which will be really interesting to see if there is something there just to kind of make it a bit more user-friendly. I think that there is. I seem to remember seeing some talk like that. We'll try and take a look at that. Definitely invest safe out there. But let's get to such a hype protocol, like why people are talking about it so much.
Sorry, you're cutting out there. What, we're going to dive in here?
Yeah, let's.
All right. So how it works, what are you getting from this diagram? I'm just seeing, okay, so the borrower puts in their own funds, it's 25 ETH. I guess this is Gearbox. And then there's some there's liquidity providers who are also actors in the system. So I guess similar to how people add liquidity on decentralized exchanges, they put in funds, which I guess are what the borrower borrows from. So here they've put in 75 ETH. And this is, I guess, an APY that the liquidity providers are earning, averaged over 30 days. So that allows the borrower to leverage up, to borrow 3x what he's put in. So yeah. So at this point, his position can be the size of 100 ETH, but he's only put in 25 ETH and then borrowed the 75 ETH. I think then besides like monitoring his collateral and how that goes up and down in price and liquidating that potentially, it looks like there's also this sort of like ongoing payment of 1.7% APY that the borrower pays out of probably this 25 ETH to the lenders or the
LP. Yeah.
Okay.
That sounds right.
Yeah.
I mean, in return, of course, the LPs are taking risk with their funds. I'm assuming they have some kind of potential to be liquidated here.
Yeah. Yeah. So then I'm not sure exactly where that liquidation mechanism sits and like what risk these LPs are exposed to, but I'm sure there is some. And then it plugs into, I don't know if this is sort of a generic thing that it could just be used anywhere in DeFi, or is it specifically they have to have adapters sort of coded to specific DeFi protocols?
Yeah. It seems like it's composable. Like anyone could write it plugging into anything, I suspect. But I think we'll see. Like one of the things that I'm seeing is that Gearbox works very hard to be customizable and composable.
Yeah. Okay. Anything else we want to see here? Decentralization at the core, composable, generalized. There we go. Decentralized, non-custodial. So like any great DEX, like Uniswap. And it's gas optimized. So that'll be interesting to see how they do that in the code. Okay, so there's a 0% funding rate. So maybe this wasn't that correct an assumption where the borrower is paying a continuous stream to the lender.
Mm-hmm. Yeah, what that 1.68 is. Yeah, I agree.
Or maybe, yeah, I mean, that 1.68 might be coming off the profits of what's happening with the final money, but I mean, then I'm not sure how you guarantee there's least a stream.
I'm peeking at the overview in a different tab. Let me know, actually, if my connection decays here. But looking at the overview in a different tab, it seems like the funding rates actually are compared to regular leverage. So normally what you're doing is you're usually counterbalancing shorts and longs. So your shorts are funding your longs are funding your shorts. Whereas here, since it's coming off of liquidity pools, you don't need your party to be funding.
But I mean, that doesn't. Don't you still need to like have some incentive for people to add liquidity? Like if you're draining the.
So I assume the 1.7 is going to the LPs, but what they're saying is, let's say everybody is long ETH. There's no one who's short ETH. You'll still be able to leverage ETH here. Whereas traditionally, I think this is something that Squeeth was running into a little bit, and why CrabDAO opened up. You take party in order to be able to fund more people. Whereas here, there's not a counterparty who's necessarily short. As in, I guess if you were going to put this in a grid, you don't need one short to one long. You need someone who wants to put in liquidity to long.
Yeah.
Does that make sense?
Yeah, I see that. So I mean, you're
still paying the LP. You're still paying the LP for like the privilege of being able to use their funds. But the LP himself doesn't have to be taking a short position.
Yeah, I definitely see how the LP's not taking a short position. It's just sort of taking a fixed income position.
Yeah.
Yeah.
So I guess by the 0% funding rate.
Okay. Interesting. And then here's some examples, I guess. This is quite cool. Long and farm. So is this okay, you put up collateral of Bitcoin or wrap Bitcoin, USDC or DAI. You, I guess, borrow up to 5x the amount of ETH. Is it through Uniswap? And then it puts it into Yearn? Is that what's happening here?
Your guess is as good as mine. That makes sense to me.
All right. Cool. And then you see, there's the borrow rate. I mean, I assume this is still this APY that someone's paying to borrow.
I can't read the numbers there, actually. What numbers is it giving there?
Let's go down. Small amount. So for ETH...
Oh, okay. 0.66, but then the other ones are bigger. They're in the threes even.
Yeah.
Going to pay for the rights to be able to leverage your way into the curve wars.
Yeah, so it's wrap Bitcoin 5x up to 5x, and then leverage Y curve up to 10x. Interesting. Cool. Anything else you want to see here? Should we? I don't know. Maybe open this.
I think we're good. You can open the app. Yeah, sure.
Connect. Oh, I don't. Wait, I do. Oh, this is my. I don't think I have any money on this wallet. It's fine.
Gonna show us your spicy Coven positions.
Okay, close this. What do I want to do here? Close this window. Let's see. DAI credit account. So let's say ETH. Open. Interesting. Quite a nice UI. Look at that. Oh,
I actually have heard really good things about their UI.
Yeah. It sort of a disclaimer, I think, to... Is this one of those things where it signs a message on chain?
You're not a citizen of the People's Republic of North Korea? Or are you just like going full crypto anarchist here?
You've doxed me. I'm in North Korea. Yeah, so this is... Oh, I've heard of this, where you sign these, like, disclosure messages on chain. That's pretty cool, hey?
Depending on your definition,
yeah,
I suppose, but yeah.
Yeah, I think it's a cool, like, the way we can use this mechanism to like sign legal agreements. Yeah. The enforcement of legal agreements that's debatable.
I think it's be really debatable, like you just said. I do agree that it's a novel use of signing, but I mean, of course, it hurts to see financial apps that we would hope would be decentralized and censorship resistant. Like, imagine that a poor, hardworking person in an authoritarian country is trying to, like, find a way to become financially solvent to the degree that they might be able to escape persecution or something like that. You would hope that they would access to the tools. I mean, I don't know how much leverage would play into that, but it could if they're savvy.
Yeah.
And I mean, I think there is kind of a standing question for a lot of these TNCs that are getting signed, if they're enforceable in any way. I guess it would be the best of both worlds if it appeases regulators but isn't necessarily enforceable. But that's just the crypto anarchist in me talking.
Yeah. I see that this was, just noticing here, it was built in the 2021 ETH Global Market Make Hackathon.
Yes, this started as a hackathon project. Yeah.
Oh, look at that.
Mm-hmm.
I was in that hackathon. That was the start of last year. I didn't build anything as cool as this. But
yeah, it is pretty awesome for a hackathon. I mean, they've built it quite a bit since then, obviously, but I mean, still, it's amazing to see this come out of a hackathon. Like, can you imagine that in the traditional world? Like, the Robinhood app would have started as a hackathon project or something like that. It's just like difficult to even like comprehend that we are in a space where that can happen.
I guess it's just like layers of refinement that then we finally see it. It's like a nice polished app.
Mm-hmm. So it looks like you need more Coven ETH in order to be able to really get started over here.
There we go. And then
you got enough?
No. I'm just plugging in numbers. But so this is the effect. So okay, I can borrow 0.01 ETH. That's pretty nice. Or I can borrow up to funds on account. So I think this borrows 3 ETH, or does it borrow 4 ETH?
I'm not sure. I'm not sure. Into that, drop me your address. I found an address of mine that has one Coven ETH. I can send you.
Okay. You can just, I guess, do it. Here we go. Copied.
Do that on the side. And now that Frame lets you send directly,
yeah, I just sent Will my.
So yeah, you keep on looking at that, and I'll send it over in the meantime.
Send him my private key and my seed phrase. Hope he does some good stuff with that.
Thanks. I really like your board. Do you have any, by the way? Because I only have 1 ETH, so I probably won't be able to send you the whole thing.
I don't have any, but I think we can do fractions.
Send okay, so let's see here. Amount of ETH to send, so send 0.99. Send transaction. Sign. Oh wait, I forgot to unlock the signer. Wait a second. How do I do that again? Yeah.
Where's my money, William?
Oh, that was me putting it. It's on the way.
All right, sweet. Yeah, we promise we'll get into the contracts after this.
And
we can jump in, I think, and just sort of.
Yeah, that's true. And come back to it. Yeah, that's a really good point.
Yeah. Okay, so I mean, let's just read the description. Generalized leverage protocol allows you to take leverage in one place, then use it across various DeFi protocols in a composable way. So you could add liquidity, as we discussed, and earn higher API than adding liquidity on dexes or farms. Or you can borrow, obviously. And look at that, 5 audits. That's pretty cool. Pretty good to see.
It looks like some of them did different things, which is actually really interesting. 2 of those are from PeckShield. And then you've got like Consensus. It sounds like Consensus just for them, which is interesting to see also. Mixed Bytes and Chain Security, also great auditors. Great to see them there. Yeah.
And they've got a bug bounty, which is also good to see. So there's lots of good.
Absolutely.
good security practices here. All right. Straight in contracts.
Straight in, let's do it. So yeah, you just ran through that. It's interesting also that this talking about how you can set things. I think that's also really nice.
You got out a little bit there.
Oh, whatever.
Yeah. All right. Where are we going first? Core.
Let's take a quick look. Yeah, let's do core.
All right. Core. ACL.
Access control is.
All right. So that's just sort of an access control ownable, but generalized for probably different permissions.
Yeah, I'm assuming.
Account factory. Do they have an account? No. Account mining. Address provider. Data compressor. Interesting. Okay.
Yeah.
What? I'm now at the account factory. Wow, this is cool.
Account factory. Okay, cool.
All right.
Diagrams. Yeah, I've actually seen a little bit more of that recently. Like diagram.
Like the recent one was Zora V3 just dropped. I know they're pretty good at their documentation, and they love. There's some really cool like ASCII diagrams, and then Curve obviously is the famous one to have that little linear graph.
Curve. Yeah.
Yeah. All right.
Cool.
So
yeah, you might want to make your screen a little bit bigger.
Yeah, sure.
And I guess this curly brace import has really taken over the universe at this point, which is really interesting for me to see personally.
Yeah.
Like, I really do not think I ever saw that before, like, months ago.
When did this?
And now, like, all the cool protocols are doing it.
Yeah.
Oh, copyright. Interesting.
Oh, hey, yeah. Do you know what this license is? BUSL?
I don't. I saw they had a licensing section in the README, but I don't know what it means.
All right.
So we're in Solidity 0.7, and they're explicitly bringing in the new ABI encoder, as in old Solidity, doing things like returning a struct was impossible. Like, the ABI encoder couldn't handle that. They made a new ABI encoder which can, and depending on which Solidity you're using, you can't import it. You have to import it in different languages depending on which Solidity you're in, because it used to be a lot more experimental. So it used to be Pragma experimental ABI encoder or something like that. And starting in 0.8, it's actually the default encoder. 0.7, and it looks like they need to do something like return struct or something like that. So they're actually explicitly using ABI encoder 2.
Okay.
Using OpenZep.
Yeah,
so that gives them sets, safe math, and clones. Interesting. Clones is the minimal proxy, if I remember right.
Yeah, proxy clones. Then some interfaces for their contracts: account factory, account miner, credit account, credit manager. This also looks like...
I can't figure out how they're breaking up those ports, like, the line breaks. It's a bit interesting for me. Like, I hadn't figured out exactly what it is. Like, you have 3 OpenZep ones, then you have their interfaces. I get that. But then, like, why is reentrancy guard in the next one? Maybe...
That is weird.
Not sure. And then libraries on the bottom.
True, yeah. I would have put this up there.
Yup.
All right. So let's get into it.
I like that contract level NAT spec here, by the way. At notice creates, holds, and lend credit accounts to pull contract. Like, nice job. I think that's great.
Yeah. More NAT spec, please. We love it.
Yeah. We have them using that library right there, enumerable set. All right. And let's take a look at this diagram real fast. So we have VA. I think that's a V at least. A1, yeah. VA2, VA3, VA4. head, a tail, and an address.
So this is
We figured out what VA is?
No, but account factory. No.
I suspect the A is account, but yeah, I'm not sure.
Virtual account, maybe? I don't know.
Oh, not bad.
But is this basically they're saying that this is like a linked list structure? Is that what they're going with?
Maybe.
We never know.
Oh, there's next credit account there. I suspect that these might be. Oh, okay. This is a guess. I'm totally not sure about that. But being that the next thing there is that next credit account, I suspect that this is how it figures out where to source liquidity from. It kind of is prioritizing by address. So I'm going to guess right now and go on a limb that as opposed to something like Uniswap where all of the funds are pulled together, it sounds like here funds, even once you're providing them, are very specifically associated with a certain provider. Like if I swap through a Uniswap pool, we wouldn't say like I swapped into DAI using your DAI that you provide. This whole big pool, everybody's in it together, and fees are just distributed per capita. Whereas over here, it sounds like they're specifically associating certain funds with certain accounts, but this is a total guess. I could be like way off. And that's why you need a head and a tail, because you kind of have this set of people providing, and then you have the head like where you're taking from first and the tail, and then after the tail is address 0, there's nothing left.
Yeah. I'm not sure if it's like sort of to model the like where the liquidity is coming from, because that just seems so gas inefficient. Like you would have to do quite a lot of looping.
Yeah. So I mean, I'll just keep it as a guess for right now.
Anyway. So with the head and the tail.
I see that's what they're using the set for. So flexing like the little itty bit of math that I know, the difference between a set and array is that in a set you can't limits. And to degree this makes sense over here, like let's say I've provided liquidity twice or whatever it is that we're keeping a list of here. It sounds like we're in a situation where we don't want me to be in the list twice. We want everything stated with one entry. So by making it into a set, that means that even if I add liquidity after I've provided the first time, I won't end up with 2 entries in the array. I'll only be in there once.
Yep.
That sounds like magic, but it probably, of course, you were saying, which is the gas. How are they dealing with gas once you have a lot of people in these sets?
Yeah. I mean, they might just have a sort of in this set object like a mapping and then an array, and the map would say like with the Boolean if the thing's already in there or not. That way you could.
I don't think so, but you know what? I'm actually going to look that up on the side, and I'll try and look that.
Yeah, drop a link if you find something because that might be interesting to look at.
Sure.
Okay, so constructor. We've got another cool diagram. At the constructor, the head and the tail both point to VA1. Still don't know what VA
Interesting.
is. Some account, most probably. And then we've got this. I see this pretty often. This is like an auditing code. Often, like people.
Well, do you know what it means?
No, but often people will like put these next to lines, and it sort of links to some sort of like maybe an audit, and this will be like some code of like something that was uncovered in the audit. Yeah, but I'm not sure in this case. Or it will link to like a specific mapping of like errors or revert messages. So you can have longer string reverts, at least. Yeah. Okay, so let's look at this constructor. Address provider, we're plugging that in as an address, and then setting up this ACL trait with the address provider. It can't be address 0. We are.
And they're using. Wait. Are they? They probably have a library of errors with error messages. That's probably how they're doing that.
Yeah.
That's a cool way of doing error messages, though. I like that.
Yeah, it does. It doesn't like pull it through right to the when you're getting it on like Etherscan or something, but you can always look it up as long as you make this stuff like verified and open source.
Also, but I'm saying, like, as we're reading the code, we get what that's supposed to be. The word. It also, since it's just the name of like the enum or whatever it is over there, they can use as many characters as possible. There's kind of like, I think, a famous like intermediate, which is if require error messages get longer, they actually take up a lot more space in the contract. The line I usually see people put it at is 32 characters. Like once you've jumped past 32 characters, they take a lot more space. I think recently I saw something even that it might even be better to keep them lower than that. But this way you can have like a really terse error message, but your enum could be very long.
Yeah, yeah, yeah. Well, the 32 characters is the 32 bytes, so that's one word or one slot in Solidity. So that's where that string length limit comes from, and then beyond that, you're taking up multiple slots. Cool. Credit account. All right, so we're setting up some contracts register here. Then master credit account basically gets the address of a new credit account that you create. Then they initialize it.
This actually reminds me a little bit of Bancor's old setup where I can't remember the exact name right now, but they would have this one contract which was always the entry point, and you could assume that it wouldn't get upgraded and like move addresses or something like that. And then you would query it to get the address registry or something like that. It sounds like you're looking for a registry, but you need to go through the address provider to get it.
Yeah, interesting. Yeah, these registry patterns they seem very useful at times.
Yeah. I mean, a lot of times out there, you hear people talk about upgradable proxies, that you put a proxy in front, and then anytime you need to upgrade, you just change what the proxy is. A lot of people are really not into it. I'm pretty against it myself, for what it's worth. But there's developers who are a lot better than me who are against it also. It's kind of a contradiction to me. Very, very big linchpin in being decentralized and censorship resistant. You want guarantees that the code that you're looking at won't change. So the question then becomes like, how do you build a system that's transferable, you're still able to upgrade a contract? So this is a setup that makes things just like a little bit clearer, I would say, without having to deal with something like an upgradable proxy where like things can change under the hood and it'll be so difficult to see even.
Yeah, exactly. We have this credit account. So I pulled out the credit account contract as well because we're creating a new one here, master credit account, and then we're initializing it. Do you want to just check out this one?
Yeah.
Okay, so a credit account implements generic credit account logic. Very cool. Token balances, general parameters, borrowed amount. Okay, cool. Cumulative index, open and block, initialized. Approves tokens for third-party contracts. Okay, so this thing probably has infinite approval.
Interesting. Yeah, that could be. Move things around.
And they execute financial. Okay.
This is making me think that like when we saw liquidity provider, I think both of us started thinking kind of like AMM structure. I wonder if this is more like a vault. You know what I mean? Where people lock their funds, but instead of like, you know, say something like MakerDAO where I lock my ETH and I get DAI, here they lock their whatever asset in a vault with their kind of risk preference, what they do, things like that. And that's like, you know, then someone else comes and invests those funds for them. Might even be a bit more Yearn-like in that sense. Like I'm locking up my money here for it to get by a different party, whereas in Yearn, here the different party are people who want to come and take out leverage.
Yeah. Yeah, it does seem much more like a vault structure to me. especially because there's like multiple. Well, once people withdraw the funds or use it programmatically, there's multiple like use cases of it. Yeah.
Cool. Very cool. Okay, so we've got the credit manager. If there amount borrowed to this account, I would have thought that would be amount borrowed from this account, but it could be that I'm still not really understanding what the accounts are. And maybe really this is where borrowed funds would live. And interesting. Connects credit account to credit account address. Restricted to account factory owner only. Credit manager borrowed amount. Yeah, you know, I am starting to think that this is where funds that are active go. Like, you know, if my 25 ETH and then the funds that are being provided by the liquidity provider plus my funds go into an account, I think.
Yeah, potentially.
But I could be wrong. Yeah. There's a initialize here.
That's
right,
what we're calling
because it's cloned. Yeah.
Yeah. Cool. Quite a short contract.
Parameters.
Oh, there we go.
Yeah.
Connect to. Should we go back to this one and then?
Yes. Provides a new credit account to the pool, creates a new one if needed. Yeah, sorry, what were you saying?
Oh no, I was just finishing this up. So they add credit account. You can see where that is. Yeah. Okay. Okay, so they're basically setting it up.
Everything is a clone of the master credit account, basically.
Yeah. Where were we? Sorry, I think
we were just at the end of the constructor.
Yeah.
Yeah, this was the next function. So this is adding a new credit account, which it'll. Oh, wait a second.
It adds to the left side, so the head. Wait.
So that's before you've got those four right there. It looks like it creates kind of a second line of accounts because now VA1 isn't on the same like path as VA3 and 4.
Yeah, potentially.
Maybe that, let's take a look at the code there. Maybe the code will help us figure it out a bit.
Okay. Take credit account.
So take account. So borrowed amount, cumulative, index at open are things that we see you need for opening accounts. If there's not one in stock, so it creates a new one. Address result equals head. Head equals next credit account head. Next credit account result equals address 0. Not following this so well. Like, I see that we're making the next credit account into the head on 162. At least that's what it looks like to me. And then I'm assuming the result is like the next place. You like this to linked list before. It's saying that once you're at the head and you're moving to the right, I'm assuming that's the result. Like, the result is what comes next.
Yeah.
And it's setting that to address 0. And I get that's how it's kind of pulling it into here. But I guess I'm not really understanding what happens to VA2, 3, and 4.
Yeah, me neither.
And then it connects. See that connect to function get used. Then it calls connect to on the result. Even though, didn't we just make that address 0? I'm a little bit confused. Oh no, this is result the global variable. Not something, and this is result array, I guess. What is result? Do we know? Yeah.
I think this is not set to like the last of the linked list, something like that.
I thought that was tail.
Maybe you're right.
I'd be looking for like a mapping or something like that, but it could be it's coming from like one of the layers or something, like one of the ports. So yeah, I wouldn't worry about finding it the second, because that'd be like a whole big chase to chase that down.
Yeah. Where are we here? Take credit account.
Yeah. So it connects to this. We're not 100% sure which account it's connecting to. That I'm kind of no, because then it would be head. Kind of, I like want that to be head in my mental model. That I get the feeling my mental model is off here, and it returns the result, which is an address. So that much we can say. We know from line 156 that this is returning an address.
Yeah.
So we can see that whatever result is, it's some kind of address. And yeah, and if you look also at the event on 172, it's called initialize credit account. Like I'm guessing that means this new account. Address result head right there. I'm up. Whatever. Okay, yeah. Not my finest moment. So the result is the head. I'm not entirely certain why it's being called the result right here, but we're making this new head. And we're setting that as the next credit account, and kind of the next one after it will be address 0. So it's kind of on its own track where it's the first account, it's at the head, then address 0, and then we're connecting to that. So like, you know, we're actively using it. It looks like.
Okay.
Cool. Should we keep on moving?
Yep. Let's do it. All right.
Take account back and adds it to the stock. So it looks like there's an account that, okay, so now I'm kind of seeing that there's this stock. I'm guessing that's like the VA1 through VA4. It seems like aside from the stock, there's an account that's being actively used. I think that does make sense to me. It's kind of like you have the queue of accounts that you could use, and then you kind of take out of those, I'm assuming last in, first out. First in, first out. And you start using it, and that's kind of its own timeline, as it were, and then you put it back when you're done, it seems. So over here we have VA4 at the tail. So once you've used it, you kind of put it in at the back of the queue.
That is pretty weird, but I get what you're saying, yes.
Okay, so this is also credit manager only. Require credit account set contains used account. Otherwise, okay, yeah, I guess that stops someone from saying, hey, take a look at this contract. It's totally Gearbox account. That's not malicious at all. Please put it in the back of the queue or something like that, and make sure that it's actually something legit that the platform recognizes. I'm wondering if this is a flash loan protection. I don't have it completely worked out mentally, but that screams flash loan protection to me.
Yeah, with checking block numbers and stuff.
The fact that you use it and close it and block. Like, that just sounds like something that would have to do with a flash loan. Like, I used it, I overwhelm something with funding either from it or that I'm putting into it, and then close it inside the same block so I can reap the profits and pay back the flash loan.
Yeah.
I don't have a clear mental model to figure out if this is like they're preventing this from being used for a flash loan, or if they're preventing a flash loan from somehow overwhelming the system internally. I suspect it's the second, but I'm not sure. That's the joy of doing this. I just sit here and guess. Yeah, so now we see the next credit account of the tail becomes the used account. So it was formerly the tail, now will be the used account becomes the tail. And it says tail is used account and fires off an event. All right. Get next is just a view function that, given an address, will tell you what the account is, like what the account is. Return address 0 if it's the tail. So yeah, that gives you a simple check for the tail. Incidentally, you can just say that, like, you know, if get next the address that you're looking for is address 0, then you know it's the tail. That's useful for any reason, but yeah. So similar to using one, it looks like also here's creating a new one and putting it in the tail. Before we were looking kind of at the max account. I think that would be a little different. So yeah, and that just adds a new account onto the end. I assume that code-wise is going to look a lot like returning something to the tail.
Yeah, potentially. Add credit account. We've already checked this one out.
Oh yeah, because we needed it for the master credit account also, right?
Yeah, you're right about adding to the tail.
Cool. So let's just keep on running then.
Take out.
Takes unused credit account out and connects it with toParameter. Okay. So this is called configurator. I love that name. Just like, you know, configurator. So it checks stock if the head account is head and net is next credit account head. So that like just basically resets what the head is and takes this off. And it sets the address 0 as kind of the next in line over here. Else require next credit account, prev credit account, next credit account for prev. What's prev? What's prev? And it stands for previous. I just don't see it being set. Is it one of the arguments in the function?
Yeah.
Oh, there we go. Okay. So, and I'm assuming that's kind of like this. That would be credit account. I wonder what previous is supposed to be. Next to credit account previous now becomes the credit account. Oh, those two need to be the same. Next credit account. Oh, okay. So you need to input the address of the account before this account.
Yeah.
Which now I get it. If so, that doesn't. There isn't anything it's previous. So I don't know exactly what you put in, but it doesn't get checked anyway. You should be able to put any address there, as in it only validates the previous that you're putting in if the credit account itself is not the head. And then it just validates that you're actually putting in the addresses right. Okay, that's cool. Fine. If it's the tail, so then you just make the tail previous. Otherwise, next credit account previous is next credit account of the credit account. Okay, yeah. All right. So now it's just kind of reassembling that linked list basically.
Yeah.
And it makes the next credit account of this credit account 0. Fires off connect to, as in it activates it, and removes it from the account set.
Yeah. Take for
All right. Yeah. So I still don't have like a clear model for like what this connect to is doing. Like it makes me feel like that's kind of when the funds become like active or used, and it has to be out of this set in order for that to happen. But I can't say I have that like super duper clear right now.
Yeah, me either. Mining. So this is probably reward mining, right?
I'm guessing. Adds
Okay.
credit accounts, credit token to factory. Provide approvals for protocols and tokens, which will be offered to accept by DAO. All protocols and tokens in the list should be non-upgradable contracts. Account mining will be finished before deployment. Any pools and credit managers. So I'm not sure which mining this means. I'm kind of guessing what it means is like. Actually, there's really two places where I could see this being relevant. I don't know if either of them are correct, but maybe either if a token wants to incentivize people taking out that token on leverage, which just sounds like a bit, I don't know, there's something about me that's a little bit queasy about that. Like, you know, yeah, that's right, guys, take 10x on our token. We'll help you out with that. Like, you know, I don't know. Just like gives me mega hex vibes or something.
Yeah.
Alternatively, if something or Sushi wants to incentivize using them as the platform for conversion. So like if I'm going long ETH using DAI as collateral, so there's going to be some swapping of DAI into ETH, probably repeatedly even. So if Sushi wants to incentivize, Sushi being the platform that we go to, they can add in additional Sushi rewards, which is actually, I mean, Sushi's a good one to pick on here because that's very similar to the setup that they have in one of the themed side things. I don't even remember which, where they give the extra rewards for providing liquidity to certain incentivized pools. Which one is that?
MasterChef V2, I think.
No, not the Master Chef. The one where like there's the extra bonuses, the Sushi X Sushi. But that is still Master Chef. Whoops.
Yeah, because so MasterChef is when you stake your LP tokens. That was the first one, and then you would get rewards. You get Sushi rewards on top of that, and then I think in V2 or V3 or whatever, one of the upgrades, they made it so that you could stake, you could get those rewards, and you could get some extra token rewards on top of it as well. So like whatever token there that wants to incentivize their liquidity on Sushi. I think it was V2. Could you check that out? Master Chef V2.
We're up against time. I'd say we should probably just keep on running for it, if you don't mind.
Fair. Yeah, let's go back.
Yeah, sorry about that. What do we do here? Require is mining finished, errors mining is finished. So it seems like that has some kind of time cap. That probably has to do with that comment on line 310. That has to be early. And so that makes an immediate connect too. And for mining approvals length, iCredit account tail approved token. Mining approvals I token, mining approvals I swap contract. I'm not getting it.
This is
as in one. There's some array of approvals which has probably some kind of struct in it, and that struct has a token field and a swap contract field, which I'm assuming you're able to swap where you're supposed to swap it. But I'm not, unfortunately not intuitively just pulling that all together. Let's keep on going through these mining functions and maybe able to kind of pull it together as we go through. So this adds pair token contract to initial mining approval list. These pairs will be used during account mining, which is designed to reduce gas prices for the first and reusable credit accounts. So it sounds like there's some kind of epoch period of time, something like that, where there's I'm like pre the leverage stuff opened up. It's just like incentivizing using. No, that doesn't make sense. I don't know. I need to understand this mining stuff better. Zero. Data types, mining approval, memory item, mining approval token, and then it pushes that into mining approvals. Not figuring it out, unfortunately. Like, I get that it's taking in, it looks like an array of structs, validating them, and then pushing them into this array of mining approvals. But yeah, unfortunately not more than that. And
Yeah,
then the next one looks like it's gonna finish off this mining period.
which just sets this to true. Yeah.
Yeah, and it's a one-way trip.
Yeah. Interesting. Yeah, so I don't know exactly what they're doing with this mining approvals array. Check stuff.
Oh, that's got before. Yeah, like it just makes sure that there's more, and if there isn't, it deploys one itself.
Okay, cool.
Okay, cancel that. Be straightforward.
Yep. And then
This just gives an account of how many are in the set or the stock.
Yeah.
And yeah, credit accounts, credit accounts, ID, returns address, return credit account set at ID. So yeah, that one just tells you like at a particular index in this, and you also have one that just tells you if something is recognized or not, which is that contains. Cool. So we can like totally speed run maybe like one more, but it would have to be like, you know, super fast mode.
What do you want to speed run?
Leverage actions, actually. What was that?
Where? Leverage actions? Where do you see that?
It was in the directory you were just in, I suspect core. Oh, credit. Yeah. Fun.
Okay, speed run time.
All right.
So a ton of
mode.
Oh, I see a Yearn V2. Hey, that's cool.
Yo.
And
Uniswap and everybody. Yeah, like everybody's there. Leveraged actions is reentrancy guard. Uses tons of libraries. Address size.
So we've got some fees. Oh, wow, nice. Okay, fee size 3. These are just lengths. Okay, so we're going to be probably unpacking.
It's packing. Yeah, it's packing something. Something packing. Contracts register is immutable. That'll be set to the constructor. Needs the address of the WETH token. Long parameters. Sorry.
You could do more struct packing here. Look at this. So there's this slot, this slot. These addresses could be. Those are 20 bytes each. So no, they couldn't actually be bunched together. This is okay. Yeah, everything here.
Addresses are 20 or 32.
20 bytes, I think.
Okay. I thought for some reason I felt like I saw conversions into bytes 32 here and there, but I'm not sure about that either.
I don't know. Or maybe there was Vitalik did propose once to extend them to 32 bytes, but I don't know if it happened.
Oh, okay.
Oh, cool. Anyway.
All right. So then we have these actions, which is someone either going short or going long. It looks like, or maybe there is a counterparty because it needs an address for a short swap or a long swap. Interesting. Has versioning in it. So this is version 1. Registered credit managers only is a modifier. Okay. Address provider can't be 0. Set register sets up with. Yeah. So open short uni v2 is going to be the only one we're going to have time to see.
Is there no long?
I'd say let's just pick one and take a look at it.
Open long, open long, open LP.
Bullish up only. There are no longs. It's only short. It's a bear market. Open short UDV2. You need the route in the minimum. Those are classic UDV2 V2 parameters. The path, deadline, and then there's something called the long params, and possibly a referral code. Fascinating. Okay, so you have the collateral uses the credit manager. And it's just looking for an underlying token there.
Underlying. Okay.
Yeah,
so this,
you need the path length to be long. Yeah.
And then it checks that the right one in that path length is a collateral.
Yeah.
Okay, so then we are doing something here, swap exact tokens. So on Uniswap's router v2, we're calling swap exact tokens. So we're doing a swap. That's this function signature.
Function selector. Yeah.
Selector, sorry. There we go. And then we're passing in the parameters here. Deadline. And then we're calling open short. Should we go look at that?
Yeah, let's look at that real fast, and then we'll have to call it a day.
Up. All right, there we go. Swap contract.
So get adapter or revert, get token or wrap ETH. All right. So like this basically gets an adapter for it. Then it wraps ETH if it's ETH, or otherwise gets the token. Takes the balance before, provide credit account allowance, short swap contract token in, so it approves. Short swap contract function call. Interesting.
This is where we're doing the short, I guess. We're actioning it. Then there's
and address asset open long. So it does sound like there is some kind of counterparty here.
Yeah.
But it's like managed with this liquidity somehow. Would have been cool to dig into this more. Unfortunately, we are going to have to call it a day over here. But this has been super cool to look at. I'm really happy we even made it through that first contract. Go us. And yeah, if anyone else is interested in digging in, Gearbox Finance. And yeah, this has been another Solidity Friday from Linum Labs, providing the future of live streaming reading Solidity code. Or something like that. All right, see y'all next week.
See you.